So molecular equation is the balanced equation. So starting with the reactants, I'm going to leave room for the coefficients, which are the numbers in front. So FeCl3, aqueous, 3 aqueous, plus leaving room for the coefficient. If there's one, NaOH, Q reacts to. So for my products, I'm looking at, it's going to be these metals that are reacting, right? So I'm looking at this is on the back of page, this is on 68. Mine's from my lab from last semester, so it's a different page. But, so I'm finding iron 3 with Cl, just to double check. FeCl is aqueous, and then to displace to OH, FeOH. OH is right here. Fe to OH is going to be a solid. So I'm going to put, leaving room for a coefficient, if there is one, Fe, and then OH, and then solid, plus, and then for Na to OH, which is right there, is aqueous. So they both start off aqueous, and then Na is going to go from OH to Cl, chloride, Na to Cl is going to be aqueous. So this is a pretty good example of a double displacement, I guess, right? Oops. Because one's solid and one's aqueous. So then Cl, and I'm not putting the subscripts yet on the product side because we need to go balance these. So now Fe, you could do this on the periodic table or on this list where it is 3 positive. So I'm going to put 3 positive, and then OH, hydroxide is -1, and then Na is +1, plus Cl, -1. And I can do the same thing over here. But these individual compounds are already balanced. That's why chlorine has a 3 down here. So Fe is 1, and then chlorine is 3 to balance out this 3. So we're going to do the same thing over here. So this OH, we need to have 3 of these to make a -3, because the iron, since the iron has a +3 charge, and this is only -1, we need 3 hydroxides. These are balanced. So the subscripts are done, each compound is balanced, and now we're going to balance the entire equation. So since we have 3 hydroxides over here and only 1 over here, I need to put a 3. And so now the hydroxides is balanced because now there's 3 hydroxides, but then now I have 3 sodiums. So then on this side, so I'm going to put a 3 over here to have 3 sodiums right here. And that balances out nicely because then that means 3 sodiums, 3 chlorides, and I have 3 chlorides right here. I have 1 iron and 1 iron. So 1 iron, check. 3 chlorides check. 3 sodiums check. 3 hydroxides, 3 hydroxides check. So this is a balanced equation. For total ionic, you're just going to put them into their pieces. So Fe, like the example. 3 plus is going to be aqueous plus Cl negative with the 3 is also aqueous plus 3Na, which is aqueous, plus, and then the same, and then -1 charge, and then the same coefficient for hydroxide. We carry it, and it's also aqueous with -1 charge, and that reacts to iron 3+, which is solid, with hydroxide with a negative charge, the 3 of them, solid, and then 3Na, oops, forgot to put the aqueous, with a positive charge, and 3Cl, aqueous with a negative charge. So then for a net ionic, just like in the example on the first page, you would do the participating ones. So I guess it's whatever makes the solid. So in this case, that would be Fe3 as an aqueous, and hydroxide with 3 coefficient, negative charge, aqueous, and they react to form the solid OH3 solid. So that's the entire thing.